Hello again, and welcome to the Moon and Back. My name is Will, and I am going to be your instructor today. I am also here with my good friend Sean, who is also going to be our instructor today. We have an interesting little bit of some exploring and instruments we're going to be doing today. But before we get into that and all of our fun learning about the solar system, we're going to go ahead and do roll really quick. So if you're here, go ahead, make sure you raise your hand really loud and say here, or just something so I know you're here. Excellent. So let's go ahead and start with Goddard von Braun.
Meow.
Thank you. Einstein.
Here.
Euclid.
Here.
Thank you, thank you. I also have Pythagoras.
Here.
Thank you, Pythagoras. Once again, Copernicus.
Here.
Excellent. Newton.
Here.
Thank you, thank you, thank you. No one has a last name. Yes. I also have Mark Armstrong.
Here.
Seems like a last name.
Yep, that seems like that one had a last name. E.T. for extraterrestrial.
Nah.
Perfect. And also my good friend Spock.
Here.
Thank you. All right, let's go ahead and move on. Like I said, we are going to be exploring the solar system. But we're going to be specifically exploring them with rovers. Now, normally in class we would be making them in the game, but that's okay. We're going to be designing them on paper. But we're going to be designing them to travel on the Terran planets because you can't have a rover on a gas giant because there's nothing to travel on. So what's the difference between a gas giant and a Terran planet? Well, a Terran planet is going to be similar to Earth. It has a crust. The Earth has a crust, Mars has a crust, the other Terran planets have a crust that if you were to travel there, you could walk on it. Maybe you didn't survive very long because your suit won't survive, but it actually has a crust, which means we can send a rover there, very much like the Mars rovers that we've sent to Mars, which we're going to talk about some of those. So, we have Terran planets. They're different than gas giants because gas giants are mostly just a huge, huge, huge composition of gas and all sorts of other chemicals that are all just because there's so much of it, they just collect and collect and collect so much of it, much like Jupiter. So, just the Terran planets where you could actually drive on them. And our very first one, so you have the sun, which isn't a planet at all, it's just the sun. You have the next one, which is good old Mercury. Good old Mercury.
So Mercury was actually named after the Roman god Mercury, who was the messenger to the other gods. It's actually one of our smallest planets that we have, and it has a solid crust. It's rocky like Earth, and it's actually really, really dense, but the majority of its density comes from its core. Its core is 55% of its volume, whereas with Earth, the Earth's core is only 17% of our volume.
And the core is that very center part of the planet.
So some other parts about Mercury.
Okay. It has a very short orbit considered in comparison to Earth, where Earth is basically 360 days. Mercury has an orbit that is only 88 days, so it's going around the sun very, very fast, which is my guess on probably why they called it the traveling planet.
Yeah,
right?
the messenger to the gods.
The messenger, because it goes really, really, really fast. So when they're looking up in the sky, they're noticing that it goes around and around, and they see it so often going so quick. What else do we have? We have the distance from the sun, which is 0.3 AU or 0.46 AU. Now, what is an AU? We're not measuring anything in space with miles. We could, but our miles would be so big, just be too many numbers. So we want to go ahead and break it down into a smaller number. So AU stands for astronomical unit, and that is the average distance from the sun to the Earth. So 1 AU, or 1 astronomical unit, is from the sun to the Earth. And because Mercury is closer to the sun than the Earth, it will have less than 1 AU. So its nearest AU is 0.3 AU, as where it's farthest, because it doesn't have a perfectly circular orbit, it has more of an oval, is 0.46 AU. So all AUs are going to be kind of an average, or it will give you its nearest and its farthest, which means it's traveling inside that parameter. All right, satellites. It has 0 satellites. Now, when we say satellite, we don't mean a man-made satellite that we sent out there. We're talking about something that is floating around it. So the Earth itself has many man-made satellites, but it has one natural satellite, which is the Moon. Mercury has no natural satellites, none at all. Now, its mass compared to the Earth is 0.055 Earths. So it is almost half the Earth, but actually it's a lot less because it's not 0.5, it's 0.055.
So that's about 5% of the Earth.
5% of the Earth, so it's very small, very small. Its gravity, so in comparison to gravity, we calculate Earth's gravity as 1. So because Mercury is smaller, it has a smaller gravity. It's less dense. Its pull on our human body would be less. So it is 0.38. 0.38. Its atmosphere, it has almost no atmosphere at all. So when you go like this and you wave your hand through and you can feel that air, you're feeling oxygen, carbon dioxide, and some other stuff. It has none of it. So if you waved your hand, it would be pretty much like waving your hand in just normal space. It has some stuff, but it doesn't have a big enough gravitational pull to keep all of that gas and air next to it. What else do we have? Temperatures. It is very, very, very close to the sun, which means it's going to be very, very, very hot. So basically, during the daytime, it is 800 Fahrenheit. So it is very hot. It's 800 degrees. Woo! Very, 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 very hot. Now, at nighttime, it is going to switch. And this is a negative 5, if I'm correct.
Yeah, that's negative 290 degrees Fahrenheit at night. And why do we think that it's so hot during the day, but it's so cold at night? Why did it lose all of its heat so easily? And one of the reasons for that is it doesn't have an atmosphere. That atmosphere helps us retain our heat, so that way we have some heat left over. Otherwise, you get a temperature swing like Mercury, where it's 800 degrees Fahrenheit during the day, and over negative 290 during the night.
Exactly. That atmosphere here on Earth kind of works just like a blanket. Keeps us nice and warm at night. Now, basically our assignment today is to create a rover that will travel to one of these planets. So we just talked about Mercury. You will get to choose any one that we talk about today, except for one of them. So keep in mind, if it's 800 degrees out there, but then it gets really, really cold, what are you going to have to do to your rover design to make sure it can survive such a harsh environment that swings one way and back to the other, okay? All right.
Also, there's a few real-life examples of why we've only ever sent 2 probes to Mercury. And the reason for that is the first one, it takes more fuel to go to Mercury and do an orbit than it does to even escape the entire solar system because of the huge gravity well that the sun has. So the sun has so much gravity that it's a massive change in your delta V in order to speed up and slow down to get into orbit around gravity, or around Mercury. Also, because we've only sent 2, what other problems do you think there is getting a spacecraft to Mercury? That might also need to be included in your rover designs.
Exactly. There might be some unforeseen things that maybe you can think of that you're going to want to include to protect your rover while it is on Mercury. All right, we're going to go ahead and go to the next planet right here, which is Venus.
And Venus was named after the Roman goddess of love and beauty. It is the second brightest natural object in the night sky. It is so bright that actually it can even cast shadows if there's no moonlight out, but Venus is in the sky. So you guys have seen when there's no moon, it's a new moon. So there's no moon, it's not a full moon. And then if Venus is so bright, it can even cast shadows. Also, Venus has a super thick atmosphere, but we're going to go over that in a second.
Excellent, excellent. So, once again, another planet with a Roman god name, So that's pretty much going to be the case with all of them, because that is when they started discovering and seeing all of these, and of course they're going to name them after their gods, or kind of the opposite. They're going to have gods named after the celestial objects that they see because they think they're gods. All right, so let's go ahead and go to Venus right here. We have an orbit. It's closer to the sun than the Earth, so its orbit is going to be smaller. 225 days. It has a planet rotation. So orbit is how fast it goes all the way around the sun. However, its planet rotation is its rotation. So our rotation, so one Earth rotation is 24 hours. That's how many times it has until we get daylight and then dark time. The Venus rotation is incredibly strange because it rotates so very slowly. It's 243 Earth days. Okay, so how old would you be on Venus, right? How old would you be if one day on Venus equals 243? You'd be very, very young, at least in age calculations, the way we count it. All right, so the distance from the sun, it is a little bit farther away from the sun, so its astronomical unit, AU, is going to be bigger than Mercury's. It's 0.714 at its nearest to the sun, and 0.728 when it is farthest away from the sun. So it's a little bit further away. Satellites. It has no satellites, none at all, no natural satellites. Its mass in comparison to Earth, so how many Earths are there inside of it, is 0.81 Earths. So it is smaller by just a teensy bit than Earth. Its gravity is pretty close to Earth's gravity. So if you were walking around on Venus, you would feel a little bit lighter. So if you were maybe 100 pounds, you might be 90 pounds or so. Its gravity is 0.9. Now, its atmosphere is incredibly, incredibly different in comparison to Earth. It is 96.5% carbon dioxide with almost no oxygen, which means we could not breathe there, even though there's an atmosphere. And there's some other stuff in that atmosphere. It's also said that the atmosphere is incredibly super duper thick. Its temperature is going to be 864 degrees Fahrenheit. Now, it's super duper hot. Now, it is pretty much going to stay 864 degrees on Venus, whether it is the daytime or the nighttime, because of that atmosphere is creating such a crazy amount of greenhouse effect that despite the fact that actually the atmosphere is so thick, very little sunlight actually gets to Venus, it traps and keeps all of that heat in there, and none of that heat re-escapes out of the atmosphere. It stays all in there, so it gets warmer and warmer and warmer and warmer. So like we talked about how Mercury has no atmospheric blanket, this has a gigantic blanket. It's like a gigantic wool blanket covering Venus.
And as a matter of fact, that blanket is 92 times thicker than the atmosphere on Earth. So it's a real lot of blanket. And as you can imagine, that's been a huge problem for our actual space programs in order to land on Venus. In fact, there's only ever been 2 spaceships that have ever landed on the surface of Venus, and they were both by the Soviet Russians. The first one to ever make it was the Verna 4, and it launched on October 18th, 1967. It only lasted in the atmosphere of Venus for 93 minutes before it got too hot for the computers to send signals back. It actually, the 92 minutes that it was in descent means that they deployed their parachutes at the very top of the atmosphere, and it slowly but surely drifted all the way down to the bottom. And as it kept going lower and lower and lower, the temperatures got so hot that it stopped reporting back.
Exactly. So if you're going to be sending your rover to Venus, you're going to have something to protect you from the heat. So you'll have to design it and draw your blueprints with it so that it has something to protect it from the incredible amount of heat that Venus has. Alrighty, awesome. Let's go ahead and move on to the next one here. More Terra planets, and this next one we know very, very, very well. This is the one, hopefully, we were all born on, unless we're E.T. This is the good old planet Earth, which has an orbit of 365 days, which is a whole year to us. Its distance from the sun is 0.9 AU at its closest, and at its farthest it is 1.01 AU. So, like we said, the distance from Earth to the sun is on average a 1, but sometimes it gets a little bit closer, and sometimes it gets a little bit farther. But on average, it's 1 astronomical unit. Satellites! We have 1 satellite. Every time you go outside at nighttime and you look up and you see that big cracker in the sky, that is the moon. That is a satellite. It is a natural satellite. You can also see plenty of other artificial satellites that we humans have put up there, but we have 1 natural satellite. Now, its mass in comparison to the Earth is going to be 1, because the Earth equals 1 Earth, which makes sense.
It's very hard math.
Yeah, it's Earth. How many Earths is Earth? 1! All right, moving on. Its gravity. Well, we pretty much count gravity in comparison to the Earth, which means the gravity on Earth compared to the Earth will be 1! How many Earth gravities are on Earth? 1! All right, making sense. Now, its atmosphere, that stuff that we breathe every single day, is mostly comprised of 78% nitrogen and 20% oxygen. That's stuff we breathe. And of course we breathe out carbon dioxide, which the trees and the different plants and the grasses use. But that is not a very large amount. Now, its temperature, on average, now keep in mind, it gets cold at nighttime and warm during the sun, daytime, and at the poles and stuff, it's different temperatures. But its average is 57 degrees Fahrenheit, which sounds about right. All right, now with Earth, we're putting Earth up here and we're talking about it as a comparison. So when you build your rover and you design it on paper, don't choose Earth, because the best thing to choose for Earth, to explore Earth, is pretty much just a 427 Shelby Cobra car. And that would be great for exploring Earth, but someone already built one, okay? Or if you're Sean, you'd probably choose
a Lamborghini Aventador.
Exactly. Those are great cars to explore Earth with. You can tell me your favorite car in your homework, but someone's already explored Earth plenty, so we're trying to get to the other planets. This is just for comparison. So, that is Earth. All right. So, we're going to go ahead and move on to what they call Earth's sister planet, Mars!
And Mars was named after the Roman god of war. It has 2 satellites, and we've sent a bunch of stuff there. Mars is actually the most observed planet in our solar system besides the Earth. But we're going to talk about that a little bit more, but we've actually been observing Mars since 1534 BC by the ancient Egyptians. It's been so far back we've been observing it, they even wrote about it in the hieroglyphs.
Woo, very cool, very cool. All right, so let's go on straight to some of them statistics, them fun informational points. So, Mars has an orbit. It's farther away from the sun than the Earth, which means its orbit is going to take longer. It's 686 days. Its distance from the sun, once again, it's farther from the sun than the Earth, so its AU is going to be more. It's 1.38 astronomical units at its closest, and its farthest is 1.6 astronomical units. It has 2 satellites, so it has 2 satellites that are natural satellites, okay? Its mass, so it's a little bit smaller It's a little bit smaller, so it's 0.107 Earths. All right, its gravity, because it's smaller, is going to have less gravity. Keep in mind, what are you going to do to deal with less gravity? Less gravity means, are you going to be able to get traction with your wheels traveling on there? What kind of wheels might you have to design? Are you going to have wheels? Its gravity is 0.3. Its atmosphere is 95.97% carbon dioxide and very low density. So most of its atmosphere is carbon dioxide, but there's not a lot of it out there. Not a lot of it out there. All right, its temperature is 95 Fahrenheit in the day, but at night time it drops. Now, why is it dropping again? Well, it does have an atmosphere, but like we said, it has a very, very low atmosphere. So its blanket is like a thin piece of like paper. So it's not keeping it very warm at nighttime. So at nighttime, it drops to 226 negative. So very, very, very low Fahrenheit. Negative 226 Fahrenheit at night. And so that is some of our statistics about Mars.
So we've actually sent 4 rovers now to Mars, and there's another one currently on the way. But the most famous one that's there right now is the biggest one, and that's Curiosity. And it weighs close to a ton. It weighs 1,982 pounds. Now that's really, really heavy for something to put up into space, because you need a huge rocket to put that up into space. So maybe your rover will be a little bit smaller, but anything much bigger, you're gonna have to think about how would we even get that into space. Now our next one is that, or more about the Curiosity, is actually really, really slow, but that's kind of the point. Its top speed is 0.09 miles per hour. So the fastest it can go is 1/10 of a mile per hour. Why would you want such a slow moving rover? Well, one, it doesn't use up a lot of energy, and the energy that you're using on that rover is going to be all solar powered. So you don't want to use too much of your energy up trying to move around. Now, the thing that's really cool about Curiosity is it actually has 10 science instruments on board. That's more than the next rover we're actually sending out there. The next rover only has 7, but this one had 10. And the reason for it is we were actually looking for water and trace elements of all the other things that we need to be able to survive. So what life needs in order to exist, the Curiosity is trying to find.
Excellent. All right, now the last one down here on our list is our good old friend, sometimes misunderstood, Pluto. Now, Pluto is not classified as a planet. It is considered a dwarf planet because it's kind of small. It at one point was considered a planet, but it is no longer. And one of the reasons why that is we believe that Pluto was not originally part of our solar system. Pluto was just wandering around in the galaxy, said, hey, I like those guys over there, and decided to come and hang out and hasn't left. So he's just a tag along and hasn't left yet. And the funny enough time, once we discovered Pluto, and up until today, it still hasn't made a full orbit. So that's kind of an interesting thing. Another interesting thing about Pluto is that its orbit, okay, instead of going around like this, it goes around like that. So its orbit is very, very strange, which is why we think it came from somewhere else. So its orbit is 247.94 years. So it takes a very, very, very long time to get around the sun for Pluto. It's a slow-moving guy in comparison to an orbit. Now, its distance, so its astronomical unit, is 29.65 astronomical units. So it is very, very far away. However, it gets even farther away at its farthest astronomical unit, which is 49.3 astronomical units.
So that's almost 50 times the distance between the Earth and the Sun for the farthest point that Pluto gets away from the Sun. Mm-hmm. It's a really long ways away.
All right. Now, Pluto has 5 satellites, so that means it has 5 natural bodies circling around it. So if you choose Pluto, that's some interesting facts. All right, its mass. It is very, very, very small. Its mass is 0.00218 Earths. And another thing to kind of keep this in mind or comparison to is Earth's. The Earth's moon is 0.17 of the Earth's mass. So Pluto is even smaller than our own moon. So it's very, very small. All right, its atmosphere is nitrogen, methane, and carbon monoxide. Now, we don't have the percentages of how much each one of these things is because we've actually never landed anything on Pluto, and we only recently got a very good picture of it, like the first picture of it ever, only very recently. So we don't know much about Pluto. So if you choose Pluto, that's going to be a very challenging one because you'll have to do some research. But a lot of your research isn't going to tell you very much, so you're going to have to be very creative and maybe have some redundancies or extra thing. Plan for one thing, but be prepared for a few other things on your rover. Its temperature, it's very, very, very far away from the sun, which means it doesn't get very much energy from the sun. During the day, it is negative 396, and at nighttime, it is negative 387 at night. All right, so that is its temperatures down at Pluto.
Now, a few things to remember about Pluto. Like we said, it was just discovered in the 1930s. So it hasn't even made one full circle around the sun since we figured out that it's been there. We finally were able to take an actual picture of it in 2015 because we sent a satellite out called New Horizons. And we sent it out in 2006, and it took all the way until 2015 till it got to Pluto and took these amazing pictures of it. That makes it so you can actually see that Pluto is white and there's a little bit of red on it. It looks very cool if you find a picture online. Now, one of the last things to remember about Pluto, it's super far away, so all the information that we have about it is either by studying the other planets or from those pictures, because we haven't had enough physical evidence because there hasn't been any rovers that have landed on it yet. So remember, when you're building your rover, you want to be extra prepared in case the surface of Pluto is different than what we think it is.
Excellent. All right, let's go ahead, keep that up for just a quick minute. Now what we're going to go ahead and do next is we have a little bit of a video of some different rovers landing on Mars. And they're going to kind of go over a couple of the different main components that I want you to design on your rover. So a little bit more on your assignment. You're going to want to get a piece of paper, maybe get like a poster board, and you're going to want to draw your rover, whatever it looks like. Does it have wheels? Does it not have wheels? Does it have something to communicate with? And you're going to draw it and you're going to label all the different parts and tell us on those different parts what they are there for. So if you're landing something in Venus, the atmosphere is very, very dense, so you're going to need some kind of heat shield to protect you. Be creative. It doesn't have to be of technology of today. Maybe it could be of technology in 10, 15 years, so you can adapt to it. So some of the different things that you have to tell us why or solve some problems. How will it land? So if it's landing on the moon, you're not going to be able to use a parachute. So how are you going to land on the moon? Now remember, the moon isn't one you can choose, it's just an example. But if you're landing on Venus, can you use a parachute? I don't know. How about how will it move once it gets to the ground? So wheels are a very good idea. But what happens if there's very big rocks? Or they talk how Pluto is filled with ice and it's very icy. So are wheels going to work very good on Pluto? How about the tires if you're going to Venus? Tires are made out of rubber. Will they survive the heat? What are the tires made out of? What is it made out of? Are they tires? Are they something else? Okay. How will it get energy? So how is it going to use these wheels to maneuver around? And so one idea, all of our rovers on the Mars surface currently have solar panels, so they collect energy from the sun, so that's one other good idea. Maybe your planet doesn't get very much sunlight, so you're going to have some sort of device that is an energy converter, and it converts perhaps the chemicals in the atmosphere into some kind of energy. So you'll have to draw what that looks like and go ahead and label it for me and tell me what its function is. Also, another thing, how will it study the landscape of the planet? And I need at least three different ways that it is going to be studying the landscape. Some examples are, one of the ways that we discover or we learn about stuff on Mars is we have a camera. So, does yours have a camera? What kind of camera? Maybe it has an infrared camera. I don't know. Also, we also have other instruments where it digs into the ground and takes soil samples. So you'll need at least 3 different things. You can always study the rovers that we've already sent to Mars to get some ideas on what that might be. Now, the other thing will be, how will it communicate with us back at home? Because chances are anything you're landing out there isn't coming home. It's going to stay out there, which means it's going to have to give us all that information. So you're going to need some sort of communication device. So you'll have to draw like a big satellite dish on there so that it can talk to us. But think about it. If it's very, very, very far away, like in Pluto, will it be able to send a signal all the way back? Or will you want to have something like it sends it halfway to Jupiter and then the rest of the way to Earth? So you get more information, so there's not information loss. Or if it's on Pluto, the satellite is going to have to be very, very big to send that information back, opposed to if it was just sitting on the moon, it wouldn't have to be as big. All right, what else? Protection from the harsh environments. So depending on where you're going, you're going to have to protect it from the harsh environment. So what types of things will you need to protect it? So you'll have to say, well, if I'm going to Venus, I'm going to need something to protect me from the heat. What are you going to protect it with the heat with? Okay, so we're now going to go ahead, let's move this off, and let's, ow! Whacked me right in the face. We're going to go ahead. This right here is a simulation of one of our rovers going to the Mars. I believe this might be the Curiosity that we're going to be taking a look at first. So this is pretty much the rover right here. It's just a simulation of how it went. This isn't an actual video of how it went. And it does it in kind of a couple ways of how it lands. You can see it has solar panels. This is how it's going to be getting energy. I'm going to go ahead and fast forward it just a little bit. Oh no. Oh no. Oh no. Oh no. There we are. There we go. Fast forwarding. I guess I'm not fast forwarding. Oh, now I'm fast forwarding. There we are. Alright, so here it is, coming in to the surface, and on the front it has a heat panel that is going to protect it from the immense heat of slamming into the atmosphere. So it's a heat shield. So right here, it's protecting it from the heat. You're going to want something like that. If your planet has any kind of atmosphere, that is something you're going to want. So as it comes in to Mars, so it has a parachute to help slow it down. But remember, we talked about the atmosphere of Mars. It doesn't have a very, very dense atmosphere. So do you think that the parachute is going to be good enough? Nope, it's not. They also needed to use rocket engines to go ahead and slow it down because the parachute never would have got it to slow down enough. There is just not enough atmosphere on Mars. So the rockets are going to go ahead and bring it down. So, how are you going to land yours? If you're going to Mars, this could be one of the ways you land to Mars. If you're going to Venus, there's gotta be another way to do it. Just gonna go ahead and lower it nice and safely down. You'll notice, how does it travel? It has wheels. And this is pretty much how they get theirs to land. You can see it has different instruments on here to study. It's going to study the Martian surface now. It has different wheels. Now, what's the advantage of having more than just 4 wheels? If one gets stuck, you still have 5 more wheels, okay? And that is pretty much how it landed. Here is one of the devices that it is exploring the surface. It has a camera, and it will send that data back. Is yours going to have a camera? Will your camera work on the planet you plan on going to? All right. Now, we're going to go ahead and take out, oh no. We're going to take out how another one landed. Once again, it's landing on the Martian surface. It's using parachutes, but once again, the parachutes are not going to be good enough because the atmosphere is not thick enough. So what they decided to do, you can see, basically it's a big, gigantic, inflatable balloon so that when they drop it, it keeps it protected. Maybe that's something you could do on yours. But then there's a problem where as it hits, it's going to just keep rolling and rolling around, which is why it's not a perfect ball shape. You can see it's kind of these triangle shapes so that eventually it's going to stop. So that is one of the ways it landed. All right, so that is your assignment, to make a rover that is going to explore one of the Terran planets. You have Mercury, Venus, Mars, or Pluto. Don't choose Earth. Once again, that would just be a 427 Shelby Cobra.
Or a Lamborghini Aventador.
Exactly. However, you're going out there. And again, how will it land safely? How will it move around? How will it get energy to do all the things it needs to do? How will it study the landscape? How will it communicate with Earth? And protection from the harsh environment. And keep in mind, if you choose Pluto, you might have to have a couple different ideas based off different things that you think it might have. Other than that, that's to the moon and back. Well, I guess today, it's to a planet and exploring it, because it's not coming back. All right, thank you very much, and have a wonderful rest of your day.
Bye.
Bye.